In this video, we're going to take a look at how we can implement a queue using an array. Now, this is going to follow a pretty similar setup to the stack in the sense that all of our data is just going to be stored inside of an array of data. So when we initialize, we're just going to do self.queue equals an empty array, or in Python, an empty list. And then we just want to implement each of our different operations using different built-in operations of our list in Python. So basically, the main question is going to be, how do we put things onto the queue, how do we remove things from the queue, and how do we peek on the queue? So like I mentioned, when we onQueue or put something onto the queue, right, we want to place it at the rear, right? Since the first thing in is the first thing that's removed, everything that gets inserted gets placed to the end of the queue itself. In order to do that, we need to decide which side of the array is going to represent that end of the queue. We have two main options, right? We could say the front of the queue, or the front of the array is going to be the rear of the queue, or we could say the end of the array is going to be the rear of the queue, right? So we have those two options for us. Now, when we take a look at those two options, basically, if we were to make the front of the array the rear of the queue, what we do is we insert at 0 the value itself, right? And if we were to do that, in turn, our dequeue would use a self.queue.pop to remove. This is because the end of the list would then become the frontmost value, being the value to remove from the queue, right? So in this situation, removing would be an O of 1 operation, but on queue, this right here would be an O of n operation, right? So because of that, we have a bit of an issue, right? Because we want to try to make this all O1, all constant time if possible. So that we could consider the other option. Well, what if we made the end of the list the actual rear of the queue, which would line up more with the, the idea of it being the end, right? If we were to do that, what would end up happening is, I'll just write out this scenario for you. Basically, our onQueue would be a self.queue.append of the value, which would be O of 1. But then we would have to remove from the front of the queue. And the main way that we could do that is we could use the delete method. So for dequeue, we would see something more like a delete off of the actual list itself. This delete would be O of n, right? So you can see no matter what, we have an ON based operation inside of this code. Now for me, because the pop returns us the actual value as well as removing it, it feels a bit more cohesive, because with delete we have to set a variable and then we have to delete the value. It feels like a little bit more work, so I think that this approach here is the cleaner one, the one where we insert at index 0 for onQueue. So I'm going to keep with this one. So just remember that this is ON, right? And then with our dequeue, we see a similar type of operation as we had with our stack, right? Where we take a look at the length of the queue being greater than 0. If it is, we're just going to return self.queue.pop. And then otherwise, if that isn't the case, I'm just going to raise an exception. I'm going to call it a queue underflow. Just like that, right? And then similarly, our peek is going to follow a similar sort of pattern, right? With our peek, we say, if the length is greater than 0, now I'm going to return the self.queue at -1. That'll give us the value that's currently at the front. Otherwise, we have an underflow, right? So these are all the same sorts of operations. This one is O of 1. This one is O of 1. And this one, unfortunately, is going to be ON, right? So we can see that the onQueue in this case has a bit of slowness to it because of the fact that we're relying on this list. And this, like I mentioned, is one of the first times where the linked-based approach is going to give us a significantly better time complexity comparative to the array-based approach. So that's something that we'll look at more in the next video. Just before we do that, I'll just demonstrate to you how this queue is working. We'll just make sure we have everything right. So we'll say queue equals a new queue. And then what I'm going to do is I'm going to onQueue a few values. And what you'll see generally with this is when I onQueue these values, I'm going to print out a queue.peek to see what the values are. And then I'm going to print out a queue.dequeue just to do one example of that. And let's take a look and see what happens. So we'll do our Python for this. We'll say aq.py. Sorry, aq.py. There we go. And you see here that when we peek, we get the value 1, and when we dequeue, we also get the value 1. So the value 1 is what's at the front, right? Because it's the first thing inserted, it's then the first thing removed from the queue itself. So that just gives you a bit more of an example of how this is generally working. And we can expand this out further and just dequeue the rest of our values and just see that it goes 1, 2, 3, right? As you can see, it goes first in, first out in that sort of format, much like a typical queue would do. So with that, we have our array-based approach. In the next video, we're going to get into our linked approach to see how we can optimize this solution here. So thanks much for watching, and I'll see you in the next video.